Hey everyone, welcome back to Quantum Science Hub. Today we are starting a brand new series. We are discussing some past paper questions from the last 5 years about stoichiometry. This video is part 2. So grab your notebook because we are breaking these questions down step by step. Nice and simple. Let's get into it. Question 1. Heating iron sulfide FeS2 in air produces sulfur dioxide. This is the chemical equation. And what is the maximum mass of sulfur dioxide produced from 120 kg of iron sulfide? Okay, so based from the question, 120 kg of iron sulfide. Where is iron sulfide? So this one, right? So the mass here is 120 kg. And the question asks about the maximum mass of sulfur dioxide. What is sulfur dioxide? SO2, right? So the question asking about the mass in here and put question mark. Okay, so first of all, we will take this as the reference, right? Because we know the mass, and that's why we will find the mole. So mole of FeS2 equals to mass should be in grams and divide by mR, right? And what is the mass of FeS2? 120,000 gram, okay? When you change it into gram, you should times with 1,000. So 120 times 1,000 is 120,000. And divide by the mR of FeS2. So you have to find the mR. So we find in here mR of FeS2 equals to, if you check in the periodic table, Fe is 56 and sulfur is 32, right? And we have 2 sulfur in here. So 2 times 32. So equals to 56. This one should be plus, okay? Plus 64. So equals to 120. And then you divide by 120, right? So equals to 1,000 mole. Next, we find the mole of SO2 and we use the concept of jumping mole. Remember, this 1,000 mole is for 4 molecules. And how many moles for 8 molecules? It is 2 times. Or we can say the coefficient or the ratio that is asking and divide by the ratio of the reference times with the number of moles of the reference, okay? So it is 8 out of 4 times 1,000 mole. So you will have 2,000 mole. And next we find the mass of SO2. Mass equals to mole times mR, right? So it is 2,000 mole times with the mR of SO2. So we find the mR of SO2. If you find in the periodic table, the mass of sulfur is 32 and oxygen is 16, right? So 2 times 16. So 32 plus 32 equals to 64. So this one times with 64. And then you will get 128,000 grams. And the option here is in kilograms. So that's why you change it into kilogram. You divide by 1,000, right? Because from gram to kilogram, you divide by 1,000. So you will get 128 kilogram. So the correct answer here is B. Question 2. 1 mole of silver nitrate AgNO3 contains 1.2 times 10 power of 24 ions. How many ions are there in 0.25 mole of iron 3 oxide Fe2O3? Okay, so first of all, we know from the information here, 1 mole of AgNO3 equals to 1.2 times 10 power of 24 ions. Okay, so we have Ag positive and NO3 negative. And how many ions is this? So this contains of 2 ions. So moles for 1 ion is 1.2 times 10 power of 24 divided by 2. So you have 0.6 times 10 power of 24. Or this is the same with 6 times 10 power of 23. And this is what we call Avogadro's constant. Okay? Now, identify the ion in Fe2O3. So we have Fe3 positive and O2 negative, right? Or I can say Fe2O3 is Fe3 positive plus O2 negative. Now balance the equation. In here, I have Fe2, but in here still Fe1. So that's why I will put 2. And in here, O3, but here is still O1. So that's why I will put 3. Now, how many ions altogether? So we have 5 ions per formula unit. So the moles of Fe2O3 equals to 0.25 mole. So the ions per formula unit is 5. So remember, 1 mole is 6 times 10 power of 23 based on the question. So how many ions are there in 0.25 mole? So we have 0.25 times 6 times 10 power of 23. And how many ions? 5 ions. So you times with 5. So equals to 7.5 times 10 power of 23. Okay, so the correct answer here is C. Question 3. When heated, copper 2 oxide CuO reacts with ammonia and H3. And this is the chemical equation. 8 gram of ammonia reacts with an excess of copper 2 oxide to produce 26.4 gram of copper. What is the percentage yield of copper in this reaction? Okay, so from the question, we know we have 8.5 gram of ammonia. What is ammonia? NH3, right? So we put the information in here. So M equals to 8.5 gram and produce 26.4 gram of copper. So what is copper? Cu. So we put in here mass equals to 26.4 gram. And what is the percentage yield of copper? So we put in here the yield of copper equals to question mark. Okay, who is the reference in here? Of course, it should be NH3, right? Because we know the mass and we want to find the yield of copper. Okay, so first of all, we should find the mole of NH3, okay? So mole equals to mass should be in gram and divided by its MR. So the mass is 8.5 divided by the MR of NH3. So we find the MR of NH3 in here. If you check in the periodic table, nitrogen is 14 and hydrogen is 1. And we have 3 hydrogens in here. So 3 times 1. So equals to 14 plus 3 equals to 17. Okay. So you divide by 17. So equals to 0.5 mole. Next, we find the mole of Cu. So remember here, this 0.5 mole is for 2 molecules. So how many moles for 3 molecules? So we are using the concept of jumping mole, right? So 3 out of 2 times the mole of NH3, okay? So 3 out of 2 times 0.5 mole. You will have 0.75 mole. Next, the mass, or I can say the theoretical yield because we calculate this one, right? So the mass or the theoretical yield of Cu equals to 0.75 mole times the relative atomic mass of copper, right? Because the formula is mass equals to mole times Mr. So 0.75 times the relative mass of copper, which you can find in the periodic table, is 64. So equals to 48 gram. Okay, now find the percent yield of Cu. If you still remember, what is the formula? Actual yield divided by theoretical yield and then times with 100%, right? So the actual yield is the best that you find from the experiment, which is 26.4, and divided by the theoretical yield, which is we find from the calculation, 48, and times with 100%. So this equals to 55%. So the correct answer here is C. Question 4. Magnesium chloride MgCl2 contains magnesium ions and chloride ions. How many chloride ions are present in 2 moles of magnesium chloride? Okay, so MgCl2, it contains of Mg2 positive and Cl negative. So MgCl2, when you break it down, it contains of Mg2 positive plus Cl negative. And here is Cl2, but in here is still Cl1. So that's why I will put 2. So in 1 molecule of MgCl2, it contains of 1 moles of magnesium ions and 2 moles of chloride ions. Since the question is asking only about chloride ions, so that means in 1 mole of MgCl2, it contains of 2 moles of chloride ions. And therefore, 2 moles of MgCl2 contains 2 times 2 equals to 4 moles of chloride ions, right? So remember, 1 mole equals to how many particles? 6.02 times 10 power of 23 particles. The particles here can be ions, atoms, or any specified particles. So if 4 mole, how many particles? So 4 times 6.02 times 10 power of 23. So this is equal to 24.08 times 10 power of 23. And you can change it into standard form, which is 2.408 times 10 power of 24. So the correct answer here is C. Question 5. A sample of magnesium is burned in air. A student calculates that 10 grams of magnesium oxide should be produced. After the reaction, the student determines the percentage yield of magnesium oxide. Which formula is used to determine the percentage yield of magnesium oxide? Okay, so if you still remember how to find the percentage yield, it is actual yield divided by the theoretical yield times with 100%, right? So let's check one by one. Option A, relative atomic mass of magnesium. So this is the AR of magnesium divided by the relative formula mass of magnesium oxide. This is wrong, okay? Because we are not talking about the AR. Next, the mass of magnesium oxide formed. Yes, that's correct. And divided by the mass of magnesium used. It's not the magnesium. So it would be the magnesium oxide. Okay, so this one is wrong. So this is wrong. Option C, mass of magnesium oxide formed. Yes, and divided by the mass of the magnesium oxide expected. Or this is what we call theoretical mass, right? So this is the answer. What about option D? The mass of the pure magnesium oxide divided by the mass of all reaction and the product. So this is not correct because we are not talking about a product. So the correct answer here is C. Question 6. 4.55 gram of zinc is reacted with 50 centimeter cube of 2.25 mol per dm cube dilute hydrochloric acid. The equation for the reaction is shown. Which volume of hydrogen gas at room temperature and pressure is produced in the reaction? Okay, now let's rewrite the equation one more time. Now put all the information below the chemical formula. 4.55 gram of zinc. So what is zinc? Zn. So you put in here mass equals to 4.55 gram. With 50 centimeter cube of dilute hydrochloric acid. So hydrochloric acid is HCl, right? And this is 50 centimeter cube. So this is a volume, and make sure you change it into decimeter cube first because all the units should be in decimeter cube. So what is 50 centimeter cube changed into decimeter cube? You divide it by 1000, right? So equals to 0.05 decimeter cube. So the volume here is 0.05 dm cube and 2.25 mol per dm cube. So this is the concentration, right? So concentration equals to 2.25 mol per dm cube. And the question asking about which volume of hydrogen gas at room temperature and pressure is produced in the reaction. So hydrogen gas is H2, and this is volume equals to question mark. Okay, so from here, we have to find who is the limiting reactant. From this question, we will find the mole, right? And who is the reference? So from here, we can know the mole of zinc because we know the mass, right? So mole equals to mass divided by mR. And the same thing with this, we can also find the mole of HCl. So mole equals to CV. So that's why this question involving limiting reactant, because we have to compare both mole and find out which one is the limiting reactant, and then we use it as the reference and use it for the concept of jumping mole to find the mole of hydrogen. Okay, now let's find both mole of Zn and HCl. So mole of Zn equals to mass divided by mR, right? The mass is 4.55 divided by 65. So the result here is 0.07 mole. Next, we find the mole of HCl. So we know the volume and concentration, and the formula is CV, right? Concentration times with the volume. So we have the concentration is 2.25 mole per dm cube times with 0.05 dm cube. Okay, so we can cross the dm cube and we will get the mole only. So the result here is 0.1125 mole. Okay, now this is the problem. So who is the limiting reactant in here? Let's find it out. Zinc and HCl, okay? In here we have 2 HCl. Now let's start with the zinc. Let's say I will take zinc as the limiting reactant. So remember, the ratio here is 1:2, okay? So if I have zinc which is 0.07 mole, so that means the mole of HCl is 2 times 0.07, which is 0.14 mole. But I only have 0.1125 mole, which is not enough. So that means I cannot use zinc as the reference. Okay, so this cannot work. Now let's try if I'm using HCl as the reference. So I have 0.112 mole, but remember, this is for 2 molecules. So how many moles for 1 molecule of zinc? So we divide 0.1125 divided by 2, which is 0.05625 mole. But in here, I have 0.07, so it is more than enough, right? So in this case, I will take HCl as the reference. Okay, HCl is the reference and I'm using this as the jumping mole to find out the mole of H2, right? Okay, so these 2:1. So how to find the mole of H2 in here? So 1/2 times the mole of HCl. Okay, so 1/2 times 0.1125 mole. So equals to 0.05625 mole. Now remember, this hydrogen is a gas at room temperature and pressure, and how to find the volume. Remember the formula, mole equals to volume divided by 24 dm cube per mole. So how to find the volume? Volume equals to mole times 24. So to find the volume is 0.05625 mole times 24 dm cube per mole. And we can omit the mole in here. So you will get 1.35 dm cube. So the correct answer here is A. Question 7. The equation for the reaction of magnesium with dilute sulfuric acid is shown. So this is the equation. And it is given the MR of MgSO4 is 120. So which mass of magnesium sulfate is formed when 12 grams of magnesium completely reacts with dilute sulfuric acid? So we know this is the mass of magnesium. So mass equals to 12 grams in here. And the question asking what is the mass of magnesium sulfate? What is magnesium sulfate? MgSO4. So the question is asking about the mass. So this is question mark. So we will take this as the reference, right? And use the concept of jumping mole to find the mole of MgSO4. And from there, we can know the mass of MgSO4. Let's find the mole of Mg. So mole equals to mass over AR or MR. So the mass is 12 grams. And if you check in the periodic table, the relative atomic mass of Mg is 24. So equals to 0.5 mole. Next, we find the mole of MgSO4. So the coefficient of MgSO4 here is 1, and the coefficient of Mg is also 1. So the ratio here is 1/1 times the number of mole of magnesium. So equals to 0.5 mole. Next, we find the mass of MgSO4. So what is the formula? Mass equals to mole times MR. The moles of MgSO4 is 0.5 times the MR is given, which is 120. So equals to 60 grams. So the correct answer here is C. Next, question 8. Calcium carbonate reacts with dilute hydrochloric acid. The equation for the reaction is shown. And this is the chemical equation. 1 gram of calcium carbonate is added to 50 centimeter cube of 0.05 mole per dm cube hydrochloric acid. Which volume of carbon dioxide is made in this reaction? Okay, let's rewrite this chemical equation to make it clear. Okay, now put all the information below the chemical compound. So we have 1 gram of calcium carbonate. So in here, mass equals to 1 gram. And this is the volume, right? The volume is in centimeter cube, and you have to change it into decimeter cube first. So you divide by 1000. So the volume here is 0.05 dm cube. And this is the concentration of hydrochloric acid, which is 0.05 mole per dm cube. Okay, the question is asking about which volume of carbon dioxide is made in this reaction. So carbon dioxide in here, volume equals to question mark. So this is again the question that involving limiting reactant, right? Because we can find the mole of CaCO3 and we can also find the mole of HCl. So let's compare both of them. So mole of CaCO3 equals to mass over mR. The mR of CaCO3, then we find it first. mR of CaCO3. So if you find in the periodic table, calcium is 40, carbon is 12, and oxygen is 16. So 3 times 16. So altogether equals to 100. So 1 divided by 100 equals to 0.01 mole. Next, we find the mole of HCl equals to Cv, right? The concentration here is 0.05 mole per dm cube, and then times the volume, which is 0.05 dm cube. And we can cross the dm cube and we will get 0.0025 mole. Next step, we have to find the limiting reactant. So who will be the limiting reactant in here? Let's rewrite it one more time. CaCO3 and 2HCl. Assuming if I take CaCO3 as the limiting reactant, so in this case, I have 0.01 mole. But remember, this HCl is for 2 molecules. So that means how many mole if I'm using CaCO3 as the reference? So in here is 2. So that means 0.01 times 2 mole, right? So I need 0.02 mole of HCl. But I only have 0.025 mole in here, which is not enough. So in this case, I cannot use CaCO3 as the limiting reactant. Now let's try using HCl as the limiting reactant. So I'm using HCl. And what is the mole of HCl? 0.0025 mole. CaCO3 in here is 1 molecule. So this 0.025 mole is for 2 molecules. So how many moles for 1 molecule of CaCO3? So we divide by 2, right? So 0.0025 divided by 2 is 0.00125 mole. But I have 0.01 mole. I only need 0.00125 mole, which is more than enough. So in this case, HCl is the limiting reactant because it is the substance that is used up first. So HCl is the limiting reactant. And I'm using this for the jumping mole to find the mole of carbon dioxide. Okay? So we find in here mole of carbon dioxide. Now let's see the coefficient in front. HCl is 2, but carbon dioxide in here is 1 molecule. So how to find the mole of CO2? 1 out of 2 times the mole of HCl, right? So 1 out of 2 times 0.0025 mole equals to 0.00125 mole. Now, find the volume of CO2. If you still remember, what is the formula? So, mole equals to volume divided by 24. So, volume equals to mole times 24. So, the mole here is 0.00125 times 24. And you will have 0.03 dm cube. Okay, now let's check the option in here. All the answer is in cm cube. So we change it into centimeter cube. So you times it by 1000. So 0.03 times 1000 is 30 centimeter cube. So the correct answer here is A. Question 9. The concentration of a solution of aqueous sodium hydroxide is 0.5 mole per dm cube. Which mass of sodium hydroxide is used to make 500 cm cube of this solution? Okay, so we have an AOH and we know 0.5 mole per dm cube. So this is the concentration, right? 0.5 mole per dm cube. And we also know the volume. So the volume here is 500 cm cube. So we change it into dm cube. You divide it by 1000. So equals to 0.5 dm cube. The question is asking about the mass of sodium hydroxide. So mass equals to question mark. Okay, so how to find the mass of NaOH? The mass of an AOH equals to the mole times mR, right? How to find the mole? So in here, do we know the mR of NaOH? Yes, we know. But we don't know the mole of an AOH. So that's why we can use this information. Mole equals to CV, right? So concentration is 0.5 mole per dm cube, and then times the volume is 0.5 dm cube. You can cross this and equals to 0.25 mole. So the mole here is 0.25 times with the mR. So we find the mR of an AOH. So if you check in the periodic table, the relative atomic mass of Na is 23, oxygen is 16, hydrogen is 1. So all together equals to 40. So times with 40 equals to 10 gram. So the correct answer here is A. Question 10. Aqueous barium hydroxide BaOH 2 times react with dilute nitric acid HNO3. The products are aqueous barium nitrate BaNO3 2 times and water. In a titration, 15.2 cm cube of 0.75 mole per dm cube aqueous barium hydroxide is required to neutralize 20 cm cube of dilute nitric acid. So what is the concentration of nitric acid? So let's rewrite this chemical equation. So we have BaOH2, okay? So BaOH2 plus HNO3 will produce BaNO3 2 times and plus with water, okay? Now balance this chemical equation. We have NO3 one time in here, but we have NO3 2 times in here. So that's why I will put 2 in front of HNO3. Now let's check the hydrogen at the left side is 2 plus 2, 4. And so I will put 2 in front of H2O. Now the hydrogen is balanced. What about the Ba? Ba1 and here is Ba1. What about oxygen? O2 plus 6. 2 times 3 is 6, right? So equals to 8 at the left side. And oxygen at the right side is 3 times 2. So 6 plus 2. So 8. The coefficient here is 1, 2, 1, 2. Okay, now put all the information below the chemical formula. We have 15.2 centimeter cube in here. So what is this? This is the volume, right? So 15.2 centimeter cube. Remember, we have to change it into dm cube. So we divide by 1000. So equals to 0.0152 dm cube. Next, the concentration. This is the concentration. So concentration is equals to 0.75 mole per dm cube. Next, HNO3, and we have 20 cm cube. So you write in here, volume equals to 20 cm cube, and then we change it into dm cube. So we divide by 1000. So equals to 0.02 dm cube. And what is the question asks about? The question asks about what is the concentration of nitric acid? So nitric acid concentration equals to question mark. Now, we want to find the mole, right? The mole equals to CV. So how to find concentration? How to find C? C equals to mole divided by volume. But we don't know the mole in here, so that's why we can find the mole of this BaOH 2 times, and then we use that for jumping mole, okay? Now, let's start with mole of Ba in bracket OH 2 times. So equals to C times V, concentration times volume, right? So the concentration here is 0.75 mole per dm cube and then times with 0.0152 dm cube. So we can cross the dm cube in here and we will get 0.0114 mole. Next, we find the mole of HNO3, nitric acid. Okay, so the ratio here is 2:1, right? So 2 out of 1 times the mole of the reference, which is 0.0114 mole. So this is equals to 0.0228 mole. Next, finally, we find the concentration of HNO3 equals to mole divided by volume. How many mole? 0.0228 mole divided by 0.02 dm cube. Okay, so equals to 1.14 mole per dm cube. So the correct answer here is C. Question 11. The equation for the reaction between dilute ethanoic acid and aqueous lithium hydroxide is shown. In an experiment, 20 cm cube of 0.05 mol per dm cube aqueous lithium hydroxide is exactly neutralized by 12.5 cm cube of dilute ethanoic acid. So which statement is correct? Okay, let's rewrite this chemical equation. So CH3COOH plus LiOH. And now we put all the information below the chemical formula. So in here we have 20 cm cube of lithium hydroxide. Lithium hydroxide is LiOH. And this is the volume. So volume equals to 20 cm cube. And 0.05 mole per dm cube. So what is that? It is concentration. So 0.05 mole per dm cube. Next, neutralized by 12.5 cm cube of dilute ethanoic acid. So ethanoic acid is CH3COOH and this is the volume, 12.5 cm cube. Now, let's check option A. The amount of lithium hydroxide is equal to this mole. Okay, the unit is in mole. So how to find the mole? Mole of LiOH equals to concentration times with the volume, right? So the concentration here is 0.05 mole per dm cube and then times 20. Remember this unit is in centimeter cube, so you need to change it into decimeter cube. You divide by 1000 decimeter cube, okay? And we can cross the decimeter cube. The result is equals to 0.001 mole. So you can see in here, the unit calculation is in 20 out of 1000, not 1000 out of 20. So option A is wrong. Option B, the amount of ethanoic acid is 0.001 mole. Okay, let's find the mole of ethanoic acid, CH3COOH. So this is the reference, right? Because we can find the mole. So we want to find the mole of CH3COOH. So it is 1:1 out of the reference. Okay. So 1 out of 1 times the mole of the reference is 0.001 mole. So this is also 0.001 mole. So this is correct. Now let's continue with option C. The concentration of dilute ethanoic acid is this one. Okay, let's find out the concentration. So concentration of ethanoic acid. The formula is mole divided by volume, right? So how many mole? 0.001 mole divided by the volume. Remember, the volume should be in decimeter cube because this is still in centimeter cube. We divide by 1000. So equals to 0.0125 decimeter cube. Okay, so you divide by 0.0125 dm cube. So equals to 0.08 mole per dm cube. So this option C is wrong. It should be 0.08, not 0.16. Next, option D. The volume of aqueous hydroxide is 0.2 decimeter cube. So the volume of lithium hydroxide, we know from the question is 20 centimeter cube, right? If you want to change it into decimeter cube, we divide it by 1000. So 20 divided by 1000. So equals to 0.02 decimeter cube, okay? While option D here is 0.2 dm cube. So it's very clear. The correct answer here is B. Question 12. The equation for the reaction between copper 2 oxide CuO and ammonia is given. So this is the chemical equation. It is also given the MR and AR value. Which statement about this reaction are correct? Okay, let's check it one by one. Statement 1. 80 gram of copper 2 oxide reacts exactly with 17 gram of ammonia. Okay, let's write the chemical equation. So we have 3CuO plus 2NH3. So the mass here is 80 gram and the mass of ammonia is 17 gram. Now let's find the mole of CuO. So mole equals to mass over MR. The mass is 80 divided by the MR of CuO is also 80. So 80 divided by 80 equals to 1 mole. Now let's find the mole of NH3. So the mass is 17 and the MR of NH3 is also 17. So equals to 1 mole. Now, you can see in here, the number of moles between CuO and NH3 is the same. But the ratio is different. So that means if I have 3 mole of CuO, I should have 2 mole of NH3. Or if I have 30 mole of CuO, I should have 20 mole of NH3. So let's say I have 1 mole of CuO. So that means I should have 2 out of 3 times with 1 mole of NH3. This is wrong because the ratio here is 1:1. So statement 1 is wrong. So option A is wrong because it contains of statement 1. It is the same with option B and C. So from here, I can quickly guess the answer. The correct answer is D because it does not contain statement 1. Okay? But let's continue with statement 2 and 3. 4 gram of copper 2 oxide reacts with excess ammonia to produce 3.2 gram of copper. So let's write the chemical equation again. So 3CuO plus 2NH3 will produce 3Cu and so on. So the mass here equals to 4 gram. The mass of copper here is 3.2 gram. Now let's find the mole of CuO equals to mass over MR. The mass is 4, the MR is 80. So equals to 0.05 mole. And the mole of Cu equals to, okay. Now before we continue, we have to know which one is the limiting reactant. So from the statement here, with excess ammonia. So that means ammonia is in excess, or we can say ammonia is the leftover. So the substance that is used up first is copper oxide, or I can say copper oxide is the limiting reactant. So I will take copper oxide as the reference. Okay? And I'm using this to find the number of mole of Cu. So they have the same number of ratio 3 and 3. So the number of mole of Cu is also 3 out of 3 times 0.05 mole. Okay, so this is equals to 0.05 mole. Now we find the mass of Cu equals to mole times MR, right? So 0.05 times the MR of Cu, which is 64. So times with 64. So equals to 3.2 gram. And this is the same, right? Because the statement says it produced 3.2 gram of copper. So statement 2 is correct. Statement 3. The mass of water produced in the reaction is greater than the mass of nitrogen. So we want to find the mass of water and nitrogen in here. So mass equals to question mark. The same thing with this. Now let's find the mole of water. Mole equals to how many? We don't know, right? So we can use the ratio in here. So the ratio is 3:1. So that means I can use 3 mole and nitrogen I can use 1 mole. Or I can use 30 mole for water and I can use 10 mole for nitrogen, as long as the ratio is 3:1, okay? But I will use smaller number for easier calculation. So I will use this as a 3 mole. So if I use 3 mole, what is the mass? So mass of H2O equals to, mass equals to mole times MR, right? So 3 times MR of water is 18. So this equals to 54 gram. Now, what about the mole of N2? The mole of N2 is 1 mole. What is the mass? So the mass of N2 equals to mole times mR. So 1 times the mR of N2 is 28. So equals to 28 gram. This is the mass for water, which is 54, and the mass of nitrogen is 28. So that means the mass of water is greater than the mass of nitrogen. So statement 3 is also correct. And therefore, the correct answer for this question is D. Question 13. How many atoms are present in 1 mole of argon? Okay, how many atoms, right, in 1 mole? As we know, 1 mole equals to 6.02 times 10 power of 23 particles. So these particles can be ions, molecules, or any specified particles. So the question here, it is an atom in 1 mole. So it is just the same with 1 mole of atom, which is equals to 6.02 times 10 power of 23 atoms. So the correct answer here is C. Question 14. The equation for the combustion of ethanol is shown. This is the chemical equation. The relative molecular mass mR of ethanol is 46. Which statement about the reaction is correct? Now we have to check one by one each option. Okay, let's start with option A. So we have 4.6 gram of ethanol. So ethanol is C2H5OH, right? So the mass here is 4.6 gram, and it produces 4.4 gram of carbon dioxide. So where is carbon dioxide? CO2, right? So the mass is 4.4 gram. Okay, let's find the mole of ethanol. Mole of ethanol equals to mass over mR, right? The mass is 4.6 divided by the mR. So the mR is given 46. So equals to 0.1 mole. Okay, next we use the concept of jumping mole. So carbon dioxide in here is 2 molecules. Mole of CO2 equals to 2 out of 1 times the reference, which is 0.1 mole. So equals to 0.2 mole. Next, we find the mass of CO2. So the mass equals to mole times mR. And we have to find the mR first. mR of CO2 equals to carbon is 12 and oxygen is 16. So 2 times 16 equals to 12 plus 32 equals to 44. So the mR of CO2 here is 44. And what about the mR of water? So mR of water is 2 times 1 and then plus 16. So equals to 18. So the mR here is 18. So we times with the mR of CO2, which is 44. So equals to 8.8 gram. Okay, so option A is wrong. Next, option B, we have the mass of ethanol equals to 92 gram. And the mass of carbon dioxide here is 88 gram. And the mass of water here is 108 gram. Okay, let's start with the mole of ethanol. So mole equals to mass over mR. The mR is 46. So equals to 2 mole. Now we find the mole of carbon dioxide equals to 2 out of 1 times 2 mole. So equals to 4 mole. Next, we find the mass of carbon dioxide. Mass equals to mole times mR. So 4 times the mR of CO2 is 44. So equals to 176 gram. So this already wrong. It should be 176. So I don't want to find the mass of water again since option B is wrong. Next, let's try option C. So we have the mass for ethanol here is 138 gram and the oxygen is 32. Now let's find the mole of ethanol. Mole equals to mass over mR. The mR is 46, so equals to 3 mole. Now we use the concept of jumping mole to find the mole of O2. So oxygen here is 3 molecules, right? So 3 out of 1 times 3 mole. So equals to 9 mole. Next, we find the mass of O2. Mass equals to mole times mR, 9 times. Then we find the mR of O2. Oxygen is 16, and we have 2 oxygen, so 2 times 16. equals to 32. So times with 32 equals to 288 gram. Okay? So option C is wrong because it should be 288 gram. Next, option D, we have 184 gram of ethanol and it will produce 260 gram of water. So let's find out the mole of ethanol. Mole equals to mass over mR. So equals to 4 mole. Next, we find the mole of H2O. So the ratio here is 3 out of 1 times 4 mole equals to 12 mole. And finally, we find the mass of H2O. Mass equals to mole times mR. So 12 times the mR of water is 18. So equals to 260 gram. And it matched with option D. So the correct answer here is D. Question 15. Calcium carbonate decomposes when heated strongly. This is the chemical equation. How many gaseous molecules are produced when 10 gram of calcium carbonate is completely decomposed? Okay, so in here we know the mass of calcium carbonate is 10 gram. And how many numbers of molecules of the gas? So carbon dioxide in here is the only gas. So we can find the mole of CaCO3. So mole equals to mass over mR. Let's find the mR of CaCO3. If you check in the periodic table, calcium is 40, carbon is 12, and oxygen is 16. So 3 times 16, so equals to 100. You divide it by 100, then you get 0.1 mole, okay? Next, we find the mole of CO2. So the ratio of CO2 in here is 1:1 and times with the moles of CaCO3. So 1 out of 1 times 0.1 mole. And you will also get 0.1 mole. So the question is asking about how many gaseous molecules. We know 1 mole equals to 6.02 times 10 power of 23 molecules. So if you have 0.1 mole of carbon dioxide gas, so that means you have 6.02 times 10 power of 22 molecules. Okay, so the correct answer here is C. Now it's your turn to solve some of these multiple choice past paper questions. You may pause the video to think for a while and please write your answer in the comment section below. I will check your answer and reply every comment. Question 16. Question 17. Question 18. Question 19. Question 20. Now let's continue with structure question. Question 1. MnO2 reacts with dilute hydrochloric acid as shown in the equation. So this is the chemical equation. Calculate the volume of chlorine gas formed in centimeter cube at RTP when excess MnO2 react with 50 cm cube of 0.2 mole per dm cube HCl. Use the following steps. Okay, now let's find the moles of HCl, and we know the volume of HCl here is 50, so we change into decimeter cube equals to 0.05 dm cube. And this is the concentration. If you still remember the formula, mole equals to C times V, concentration times with volume. So we find here mole equals to, the concentration is 0.2 mole per dm cube times with the volume, which is 0.05 dm cube. And we can cross the unit of dm cube, so you will get 0.01 mole. Okay, so the answer here is 0.01 mole. Next, determine the number of moles of Cl2 formed. So we know in here, this is the reference, right? And we use the concept of jumping mole to find the number of moles of Cl2. This 0.01 is for 4 molecules of HCl. So how many moles for 1 molecule? 1 out of 4 times the number of moles of the reference, right? 1 out of 4 times 0.01 mole equals to 0.0025 mole. Okay, so the answer here is 0.0025 mole. Next, calculate the volume of Cl2 form. What is the formula to find the moles for gas at RTP? Mole equals to volume divided by 24 dm cube per mole. So we just rearrange the formulas. Volume equals to mole times 24, right? So volume here equals to the number of moles, which is 0.0025 mole, and then times with 24 dm cube per mole. And we can cross the unit of mole, then you will get 0.06 dm cube. But remember, in here, the unit is in centimeter cube. So you times with 1000 to convert dm cube into cm cube. So the answer is 60 cm cube. Okay, that's it. Question 2. Crystals of hydrated calcium nitrate contains water molecules. The formula of hydrated calcium nitrate is this. X is a whole number. When hydrated calcium nitrate is heated gently, the following reaction occurs. A sample of hydrated calcium nitrate is heated gently. 3.28 gram of calcium nitrate forms and the mass of crystals decreases by 1.44 gram. We know the MR of calcium nitrate and the MR of H2O in here. So the question is, determine the value of X in hydrated calcium nitrate. This question is pretty easy. We know the mass of calcium nitrate, right? So the mass of calcium nitrate is 3.28 gram. And we know the formula to find the number of moles. Moles equals to mass over MR. So the mass is 3.28 divided by the MR of CaNO3 2 times is 164. So equals to 0.02 mole. Okay, so you write in here 0.02. Next, calculate the number of moles of H2O given off. From here, we know the mass of the crystals decreases. So that means when you heat hydrated calcium nitrate, hydrated means it contains of water. So when you heat it, the water will evaporate and the mass decreases by 1.44 gram. So that means this is the mass of the water that evaporates. So we know the mass of H2O is 1.44 gram. Let's count the number of moles of H2O. Mole equals to mass over MR. The mass is 1.44 and divide the MR is given, which is 18, equals to 0.08. So the answer here is 0.08. Next, determine the value of X. Okay, so we know the formula is calcium nitrate CaNO3 2 times ratio with the number of water, right? And we know the number of moles of calcium nitrate is 0.02 and water is 0.08. From here, just divide all of them by 0.02 to get the whole number. So this is 1:4. So from here, we know CaNO3 is 1 molecule and the molecules of water is 4 molecules, right? Because we have X in here. So X equals to 4. Okay, that's it. Question 3. Dilute nitric acid HNO3 reacts with aqueous calcium hydroxide as shown. This is the chemical equation. 20 cm cube of 0.015 mole per dm cube CaOH 2 times react with 25 cm cube of HNO3. Calculate the concentration of HNO3 in gram per dm cube and use the following steps. So first of all, we calculate the number of moles of CaOH 2 times. And we know the volume and the concentration. But remember, the volume here is still in cm cube. We convert it into dm cube by divide this value by 1000. So 20 divided by 1000 equals to 0.02 dm cube. And the same thing with the volume of HNO3 in here. This is the volume of HNO3, which is 25 cm cube. Change it into dm cube, which is 0.025 dm cube. Now, how to find the moles? Mole equals to concentration times volume. So moles of CaOH 2 times equals to concentrations times with the volume. So the concentration here is 0.015 mole per dm cube times with 0.02 dm cube. And we can cross the dm cube equals to 0.0003 mole. So the answer here is 0.0003. Next, find the number of moles of HNO3 which react with the CaOH 2 times. So we know the mole of CaOH 2 times in here. So this is the reference. And what is the mole of HNO3? Remember, we can use the concept of jumping mole. So we want to find the number of moles of HNO3, right? So mole of HNO3 equals to 2 out of 1 times 0.0003 mole equals to 0.0006 mole. So the answer here is 0.0006. Next, calculate the concentration of HNO3 in mole per dm cube. So if you still remember, the formula is mole equals to concentrations times volume. So we want to find the concentration. Just rearrange the formula. So concentration equals to mole divided by volume. Okay? Let's find the concentration of HNO3 equals to, what is the mole? 0.0006 mole divided by the volume of HNO3. Which one is the volume? This one, right? So 25 cm cube of HNO3. And remember, the unit should be in dm cube. So you divide by 0.025 dm cube equals to 0.024 mole per dm cube. So the answer here is 0.024. Next, calculate the concentration of HNO3 in gram per dm cube. To convert the concentration from mole per dm cube into gram per dm cube, we need to times the concentration by its MR. So first of all, we find the MR of HNO3. So what is the MR? Hydrogen is 1, nitrogen is 14, oxygen is 16. So 3 times 16 equals to 63. And the unit is gram per mole. Next, we find the concentration of HNO3 equals to 63 gram per mole, and then we times with the concentration, which is 0.024 mole per dm cube. So we can cross the unit of mole in here, and you will have 1.512 gram per dm cube. Okay, so the answer here is 1.512. That's it. Question 4. When magnesium nitrate is heated strongly, magnesium oxide is formed. The equation for this reaction is shown. Calculate the volume of NO2 gas at RTP formed when 7.4 when magnesium nitrate is heated, and use the following steps. Okay, so first of all, we know the mass of magnesium nitrate is 7.4. So where is magnesium nitrate? In here, right? So mass equals to 7.4 gram. Now let's calculate the MR. The MR of MgNO3 2 times. So if you check in the periodic table, magnesium is 24, nitrogen is 2. So this one is times 2. Everything in this bracket times 2, right? So 2 times 14 plus oxygen is 16. So 6 times 16 equals to 24 plus 28 plus 96. So equals to 148. So the answer here is 148. Next, calculate the number of moles of MgNO3 2 times used. Okay, mole of MgNO3 2 times equals to mass over MR. And we know the mass from the question is 7.4 gram divided by the MR is 148. So equals to 0.05 mole. So the answer here is 0.05. Next, determine the number of moles of NO2 formed. Okay, MgNO2 is the reference, and we want to find the number of mole of NO2. Since this is the reference, so I'm using the concept of jumping mole. So the mole here is for 2 molecules. So how many molecules for NO2? 4 out of 2 times the number of moles of the reference, right? So mole of NO2 equals to 4 out of 2 times 0.05 mole equals to 0.1 mole. So the answer here is 0.1. Next, calculate the volume of NO2 gas in centimeter cube at RTP. If you still remember how to find the mole of gas in RTP, mole equals to volume divided by 24 dm cube per mole. So this is the formula. So just rearrange the formula. So we want to find the volume, right? So volume of NO2 equals to mole times 24. What is the mole? 0.1 mole times 24 dm cube per mole. And you can cross the mole, so equals to 2.4 dm cube. But the question asking in a centimeter cube, so you convert dm cube into centimeter cube, you times it by 1000, so equals to 2400. So the answer here is 2400 centimeter cube. Question 5. 0.325 gram of zinc is added to dilute sulfuric acid which contain of 0.01 moles of H2SO4. The equation for this reaction is shown and determine whether Zn or H2SO4 is the limiting reactant. Okay, so we know the number of moles of H2SO4 is 0.01 mole. We know the mass of zinc here is 0.325 gram. So let's find the moles of Zn first. Mole of Zn. So mole equals to mass over mR, right? So the mass is 0.325. The relative atomic mass of zinc is 65. Equals to 0.005 mole. Okay, so the mole of Zn in here is 0.005 mole. Now, please take a look. So the ratio between Zn and H2SO4 is the same, which is 1:1. So that means if I have 0.05 mole, then I should have 0.05 mole for H2SO4. But I have 0.01 mole. So it is more than enough. So that's why I can use Zn as the limiting reactant. But if you are using H2SO4 as the limiting reactant, so that means you have 0.01 mole. And you also need 0.01 mole for Zn. But in this case, you only have 0.005 mole. So that is not enough. And that's why we use Zn as the limiting reactant. Okay? So how to answer this? So you can say Zn is the limiting reactant because the moles of H2SO4, which is 0.01 mole, is greater than the moles of Zn, which is 0.05 mole. And the reaction requires 1:1 between Zn and H2SO4. Okay? Question B. In another experiment, 48 centimeter cube of hydrogen gas H2 is produced. The experiment is carried out at room temperature and pressure RTP. Calculate the number of molecules in 48 centimeter cube of H2 gas measured at RTP. And this is the value of Avogadro constant. So the question is asking about the number of molecules. Okay? So first of all, we should find the number of moles of hydrogen gas. Okay? So if you still remember how to find the moles of a gas at RTP, mole equals to volume divided by 24, right? So we find mole of H2 equals to, remember the volume here should be in dm cube. So you change into dm cube, you divide by 1000. So equals to 0.048 dm cube. Okay, so here is 0.048 dm cube and divide by 24 dm cube per mole. Now you can cross the unit of dm cube, so you will get 0.002 mole. Now remember, 1 mole is always equals to 6.02 times 10 power of 23. So if you have 0.002 mole, so that means you just times the number of moles with this number. Okay? So number of molecules equals to 0.002 times 6.02 times 10 power of 23. So equals to 0.01204 times 10 power of 23. Or you can change it into standard form, which is 1.204 times 10 power of 21. So the answer here is 1.204 times 10 power of 21. Okay, that's it. So that's all about some past paper question in the Stoichiometry Part 2 question and answer. Thanks for watching. Don't forget to like, comment, and subscribe. See you in the next new chapter.